Hi, this is Kevin Trainer. Welcome to my tutorial for the coding assignment for Zelle Chapter 2. And the coding assignment is from the programming exercises uh, in, uh, in the Zelle second edition book. It's on pages 53 and 54. And you guys are going to be doing exercises 2, 4, 5, and 9. And so what I'm trying to do here is to do kind of similar things, but not the same, so we can kind of keep with the scheme that we're using in the class, the see one, do one, teach one. Okay, so when I do the tutorial demo here, that's your C1. When you do the homework exercise, that's your do one. And then when we, in the beginning of the next class, when I look for volunteers to show us the work they did, for the people who walk through what they did, that's their teach one. And hopefully over the course of the semester, everybody will get a few opportunities to do a teach one. So I want to remind you that we have here we have already from the last time I did a demo. Let me click on Finder. I'm doing this on the Mac. That I've got somewhere here. I've got the code from the book. Okay, so you ought to be able to find on our weekly schedule. You ought to be able to go find the download for the book code. We're seeing here is chapter 1 had one program, Chaos Pi. Chapter 2 has 3 programs, average 2, convert, and FUTVAL, which stands for future value. And the assignments that we have are going to require you to begin with them and to change them. So I want to make sure that you don't have to begin by typing in all the code. So even if you haven't done this yet, this is your chance to download the code, unzip it, and have it available for when you're going to need it. Okay? I'm going to be changing programs that I wrote, so I'm going to have to copy these over to this virtual machine, and I'm going to pause so I can do that now. Okay, I found it. I'm back. So instead of working with the code that's from the book, and again, I have that on my virtual machine here in a directory called code under documents. I've now copied over the project directory that I did when I was doing my practice for the tutorial. And what I've done is I've created a bunch of programs that kind of mimic the ones that you're going to be changing. So the ones that I'm going to copy are going to be different because I'm going to be doing something different than you. And that's where we are. So here are the things I'm copying from. I'm going to shrink that up a little bit so I can find it. And I'm going to fire up a copy of PyCharm Edu, as I call it. Okay. And I'm going to be wanting to create a directory, a project. I want to use the same scheme that we've used in the previous one. So, in fact, I'm going to look back to the instructions that tell me what it should be. And I see that last week we used the name for our project, last name underscore first name exercises Zelle chapter 1. So I'm going to call this new project something pretty similar. So it's going to be with the rest of my projects in the My Python course directory. And last name, first names, it's going to be trainer underscore Kevin underscore exercises underscore Zelle underscore chapter underscore 02. Okay, so that's kind of what you're going to be creating. And again, when it creates a project, if you look down here in the lower right, there's all kinds of things going on to copy the right metadata and all that kind of stuff into the project. And we simply took the defaults for the version of the interpreter that we wanted. We wanted the latest version of Anaconda. Okay, so all this makes the screen on my virtual machine blink. A little distracting, but that's how it seems to work. The nice thing about doing this on a virtual machine is I know that I'm not depending on kind of other things that I installed a long time ago that are helping me that won't be there to help you. So that's what I'm doing. Okay, so let's look at the first exercise you guys are going to be doing, and then I'll do my parallel. Okay, so I'm just finding the instructions again on my other monitor. So we're starting with exercise 2. Again, that's on page 53. So modify the average 2 program from the book to find the average of 3 exam scores. So what do I have that's kind of like that? Well, I created a program that doesn't average 2. It creates the sum of 2 things. So that's not the exact same thing, but it's going to be close. So I've got one that's called sum2pi, and that's what I'm going to be changing, right? So I'm going to copy this over. I'm just going to pull it and drop it right on the name of the project. And then I get a chance to change it. And I think we have to go all the way out to the end. So we're going to go all the way out to the end. Oh, to that directory. Okay. This didn't do what I wanted. I thought it was going to give us a name to change it right there, but we're going to say okay. Okay, now let's expand our copy of PyCharm. And here it's called sum2, so it just copied it over. Sometimes you get a chance to change the name, sometimes not. How do I change the name? Well, I can refactor it. So how do I decide what to do? Well, here's how we're going to do it. If we are given a name in the instructions for the program that we create, then we'll use that name. If not, let's just identify it by the name of the exercise. So this is in chapter 2. It's exercise 2. So I'm just going to left click on sum2pi, pick refactor, rename. Okay, and I'm going to call this chapter underscore 2 exercise 2. And why am I going to do that? Well, for the poor guy who has to grade this, which is who is going to be me, it's easier to figure out which ones to grade first if they have some kind of an orderly name. So I'm going to refactor it. You see that's changed. And let me give a double left click to open it. Now it's changed the name of the file. Okay. That's nice. But it hasn't changed the name of the comment that says what the name of the file is. Okay, so instead of sum2pi, I think we usually say file colon here too, so let's do that. So file colon space sum2pi. Okay, so let's just change the name here. chapter 2, exercise 2. So we want the comments to be up to date. So we were told to make it work for 3 instead of 2. So this is going to be pretty simple, okay? So a simple program to sum 2 exam scores. So let's just change that comment to say 3, okay? And it says it illustrates the use of multiple input. Well, multiple 2, multiple 3, that sounds fine. So let's look at the code. We've got the classic setup here where we have all of our code, all of our operational code inside of the procedure called main. And then we just have one statement that is outside of a procedure. That's the call to main. And that's going to be a pretty typical pattern that we're going to follow. Okay, so let's look at the parts of the program. I'm going to suggest to you that, consistent with what we've been talking about in class, that this program follows the pattern of input, process, output. Okay, how does that work? Well, let's see. The first thing they do is that they print it's kind of an introduction. So that's just sort of a politeness. It's not part of input, process, output. Perhaps that's be polite. So be polite, input, process, output. So then this line here, line number 8, is input. So this is where we do a multiple input, okay, by using the input statement inside of an eval, but we tell the user to enter more than one score and to separate it by a comma. And then, of course, if you look on the left side of this assignment statement, we've got 2 variable names, score 1 and score 2, separated by a comma. So we're expecting the user to be smart enough to enter 2 scores separated by a comma, and not 0 scores, not 1 score, 2 scores, not 3 scores, not 4 scores. So exactly 2. Okay. Now we're going to come to the part. So that was input. Now we've got process. Okay. Here's where we create the variable sum, and we assign it the value of the expression score 1 plus score 2. So that's process. So now we have the answer sum, and then we have output, and we do that with the print. So we print 2 things. One is an identifying string. The sum of the score is, colon, and then we get sum. Okay, now I'm going to tell you about the trick. Before I change any code, and I probably should have done this even before I changed the comments, I want to run it and make sure it currently runs. Okay? As soon as you get some code from somebody else that you're responsible for changing, don't just assume that it's going to work. It could be broken. Okay? You could spend all day trying to fix something that you got that was broken. So I'm going to run this. I don't have a play button up here to the left, so, and to tell you the truth, I don't understand why we see that sometimes and not. But if you right-click in the edit window, we do see a run chapter 2 exercise 2, so that's what we want. So we're going to run that. The monitor comes up. It gives us the right polite introductions. Enter 2 scores separated by comma. Okay, so let's say these are exam scores. Let's say we have an 88, comma 99. And let's press enter. And it says the sum of the scores is 187. Well, that looks pretty good. That's about right. That's what we want. So, okay, let's make it ours. We want to change this into working for 3 things. This is kind of interesting. So I just want to point out that when they tell us to change it from 2 to 3, if we already knew a lot of things about how to do things in a loop, okay, And if we already had things like, if we had already learned about the data structure called a list, then as soon as we've got more than two, we might be saying, well, let's put this in a loop and let's use a list and all that kind of stuff. Well, we haven't covered those things yet. So we're just going to do this by brute force. We kind of see how they went from 1 to 2. So we're just going to add a third. We're going to do it in a pretty naive way. Okay, now this will work as well for 3 as it did for 2. But would it be the right way to do it for 10 or 20 or 30? No, it probably wouldn't. Okay, and for that, we're going to have to cover another chapter or two. Okay, so let's look at this. I think we've got the comments going. We say 3 exam scores, that's good. Multiple input, that's still good. So let's get into the code. This program computes the sum of 2 exam scores. Okay, that's got to say 3. Okay, so let's say 3. That's fine. Okay, so let's go down here, and we've got score 1, score 2. Okay, I think we're going to need a third variable, so let's just do it in parallel. Add on a score 3. Okay, that looks good. And then we have an input, and it's enclosed inside an eval procedure call. And it turns out that this is it turns out that input and eval are pretty robust and sophisticated, and it turns out they'll work for 1, they'll work for 2, they'll work for 3. They really are. It really is some pretty sophisticated code, kind of above the grade that we would be coding anytime soon. So we can just we can count on it to handle 3 inputs, but we have to get the message right. So let's say enter 3 scores separated by comma. Well, no, plain English would say commas. Here's something I want to point out. When we do a normal print, okay, like down here on line 11, each one of the arguments that we pass to the print method, it gets printed out and a space gets inserted after it, which is why we can just say the score is colon, no extra space after it, comma sum. And we actually get a space if we look down here in the command prompt window. You can see console window, okay? You can see that in between is colon and 187 we got a space. So that's how a normal print works. I just want to point out that up here when we're doing a prompt, if we want there to be a space after the colon, you can tell with a little experimentation that you have to explicitly put it there. And they have explicitly put that there. So we're going to remember to do that when we're using this input in the future to keep from, because when you look at when I typed after the prompt, there was a nice space there to make it look good. I wasn't typing right up against the colon. And that's because they took the care over here to put a space in there explicitly. Okay, that's good. So we've taken care of it. We've taken care of be polite. We've taken care of input. Let's go to process. So we're adding score 1 and score 2 to get the sum. Well, yeah, to do it right now, we've got a third score. Let's just add that in. Score plus score 3. Okay, that looks good. And it says, now let's get the output. Print the sum of the scores is sum. Okay, this one was pretty easy to change. So it's probably already saved, but sometimes I get a little compulsive. I want to do, here on the Mac it's a Command S. On Windows it would be a Control S. So we have it there, and we also have up here, we have a play button, so I'm going to use that. And it says enter 3 scores separated by commas. Good. I'm going to click down here. Look, there's a space right there after the colon. It looks good. So let's add 80, comma, 90, comma, 100. And let's press enter. And the sum of the scores is 270. Well, I know from being able to add those nice round numbers that we've gotten the right answer. Okay, that's good. So you might say, okay, Kevin, you're finished testing, but I just want to tell you, testing is a big part of what we do, so I'm going to want you to test a couple of other conditions. Like, for instance, what happens if we don't give it enough inputs? Okay, let's look. Okay, so let's give it a run. Let's not give it any inputs at all. So let's just give it a enter. Ooh, didn't like that. So in the end it says unexpected EOF, end of file while parsing. Oh, well, that's true. It was looking for input and it didn't get anything. When we type things in, it's really a simple case of an input file. It's a character stream input file, and we didn't give it any characters at all, so it unexpectedly found end of file. Okay, well that made sense. Let's run it again and give it one number. Okay, so let's give it 99. Enter. Okay, interestingly, we didn't get the same message. Okay. It says, you can see where we were doing that score 1, score 2, score 3 equals eval, blah, blah, blah. And it says the int object is not iterable. Well, what's happened is that we've given it one input. The eval has turned that into a proper Python object. It is an int object, which holds an integer value. But of course the code that we have is we're looking for 3. It's looking for a list of 3 numbers, and we're giving it 1. Okay, so that didn't work. But what's interesting, slightly different input, slightly different wrong input will give you slightly different wrong messages. Okay, let's give it 2 instead of the expected 3. Okay, so let's give it a 50, comma, and a 60. Okay. Well, we've got another error message. It says, value error, not enough values to unpack, expected 3, got 2. Okay, so what it got was a list of when it ran, when it took the character string that we gave it and it ran it through eval, it created a list of integer objects, but it was looking for 3 and it only got 2. It doesn't like that. It wants 3. Okay, so let's give it the correct input. Okay, so let's just give it 1, 2, and 3. Okay, some of these scores is 6. All right, so later on in the course, we're going to be writing code to not have to trust the user so much to do the right thing. Okay, right now we're relying on the user to do what we ask them to do, and if they don't do it, our program's going to bomb out. Okay, well typically that's what you do when you're a beginner. Later on, you kind of take on responsibility to protect the user from themselves, and that really takes some other language features and strategies that we haven't learned yet. Okay, so that works. Let's see if what happens when we give it too many. Okay, so let's give it 4. And so let's give it 10, 20, 30, 40. And let's, oh, I'm sorry, we just have to hit enter now. And interestingly, it got a message similar to the last error. It says value error, too many values to unpack, expected 3. And how many did we give it? We gave it 4. So what I like is that the language features are pretty safety oriented and robust. They did about what we expected them to. And it's probably true that we're not always going to be testing exactly like this, but we've tested a lot of other things. The other thing I would test here that we haven't really tested yet is, what if we give it something that's not a number? Okay, so let's give that a run. So what if we gave it, instead of 3 numbers, what if we gave it Kevin, Pam, and Cat? It doesn't like that. It says the name Kevin is not defined, so it wants to use Kevin as a variable name. That's not good. All right. So what we can see is that that's a mess too. So we've written a program that seems to do the right thing when we give it correct input, which is about all we can expect for right now. So I think we've done a good job. And I think you've done the C1 for exercise 2, and you're ready to do the do one. Okay, so what's the next one that we're going to do? I'm going to close this. The next one is, we've assigned exercise 4. Okay, and exercise 4 says, that's over on page 54, modify the convert.py program so that it computes and prints a table of Celsius temperatures and Fahrenheit equivalents every 10 degrees from 0 degrees centigrade to 100 degrees centigrade. Well, that doesn't really work like that now, so we're gonna have to change it around. In fact, that sounds kind of loopy, doesn't it? All right. Okay, so I'm not going to do it to convert pi. So what have I created? Well, I have created something called convert inches to centimeters, convert inches cm, so that I'm going to convert that one, and then when you do your do one, you're going to convert the real one that's from the chapter. So let's see. I need to I'm going to need to get up here and resize this thing. Let me click on this again. So I've resized that, and I've got to convert inches cm. That looks good. And I'm going to pull that over on top of this, and it doesn't seem to be working the way I expected it to. So let's try it again. Let's heat that up and then heat this up and see if I can make it work. Yeah, I seem to be able to make it work there. And again, it just wants to copy it, not change the name, so that's fine. Okay, so what am I going to do? I'm going to maximize this again. And I've got something that's called the wrong thing. So we're doing exercise 4. So I'm just going to refactor, rename. And exercise 4 doesn't say to call it anything in particular. So I'm going to call this chapter _2 exercise _4. So then the poor fool who has to grade it will know which one it's supposed to be. Okay, we're going to open it. And let's see what this does. Well, this is a lot like the program that you're going to be changing, but here it converts inches to centimeters. Okay, And it says, if you look at the formula here in the kind of process part, it says that centimeters is equal to inches times 2.54. And as I remember from my grade school days, that seems to be right. Okay, so let's do this kind of in this standard way. So I'm going to first of all, I'm going to change the comment. So instead of convert inches to cm, it's now called Chapter 2, Exercise 4. Okay. And this is going to be, let's do kind of the equivalent. So every 10 inches from 10 inches from 0 inches to 100 inches. Okay, so a program that prints a a table of conversions from inches to centimeters. Okay, then that sounds good. And then I'm going to have a second line, turn that into a comment, and I'm going to say one entry in table from 0 inches to 100 inches by 10. Okay, so 0, 10, whatever. So if I'm thinking about this, if I'm going from 0 to 10, I think that takes 11 times around, if I remember right. But we'll see. All right, so we're going to need some looping stuff, aren't we? Yeah, I think we are. So here's what I have. I've got a really good way to convert inches to centimeters, but that's it. Okay. Am I going to be prompting? Am I going to be, is this going to be based on user input? No, it doesn't look like it. So that it computes and prints a table of Celsius temperature. No. So it's not, it doesn't look like that. So it looks like I'm not going to need a line that does this. Does that make sense? And when we print, are we going to be printing just one? No, it doesn't look like we're going to be printing just one, does it? Nope, it doesn't. Okay, so, but I probably am going to have a main, so let's just leave that one line up here, the centimeters line up here, and let's try to come up with some pseudocode for how this is going to work. Okay. So let's say, let's do some pseudocode. Okay, so I'm going to say for I equal 0 to 10. No, 0 to 100 by 10. Okay. And then I'm going to say I'm going to say convert So let's just not call that I. Let's be a little, so let's call that inches. Inches equals 0 to 100 by 10, increasing by 10. Convert inches to centimeters. Okay, and if this is a 4, well, I think this is probably going to be indented, right? This is going to be part of our the body of our loop. Okay, convert inches to centimeters. This is going to, and we're going to want to print. Okay, so we're going to want to print inches inches is equal to centimeters. Well, that looks about right. Okay. So that's the code that we're looking for, right? And that's going to go right in there. And we're probably going to put that code in there. So here's what I'm going to do. I'm going to take this pseudocode, and I know it's going to go inside the main, but I'm going to clip it here, and I'm going to put it up, sort of up with the code, the comments at the beginning. Okay, and you know what else I'm going to do? I'm going to take this other line of code that I know I'm going to need something like that later. I'm going to put that up there too. Okay, and it's going to go, oh, that's real code. No, I'm going to toggle it into a comment by, here on the Mac, I'm going to do command /. Okay, so now main's empty. Okay. So, how am I going to do it given the skills that I have already? Now, it turns out that I happen to know, that there is a way to use for and range and all those things to get a list that's going to be exactly what we want. 0, 10, 20, 30, 40, 50, up to 100. Okay? Well, we haven't learned that yet. Okay? So what could we do using just the statements that we know so far to get this done? Well, we know how to do a for that goes around 10 times, right? Okay, and then how do we do that? Well, we did that by something that looks like this. For I in range 10. Okay. And let's say print I. Print I. And what are we missing up here? Well, of course we're missing the colon. Right there. All right, well that looks okay. So the first thing I'm going to do is I'm just going to figure out what kind of numbers can I get out of this for I in range 10, okay? I think I'm only going to get 10 values, and that's not exactly what I'm going to be looking for, but let's just see. Let's run. Okay, 0, okay. 1, 2, 3, 0 through 9. Okay, and so what do we want? Well, we're going to want 0 through 100. So we can multiply by 10, but that would only give us 0 through 90, right? Well, let's do that. Print I times 10. I times 10. All right, let's give that a run. Well, that's looking pretty good. That's a good start, but we're one short. Okay, so instead of finishing with 10, let's finish with 11. So it's a range 11. All right, does that look good? Uh, 0 through 100. Okay, so do we really want to print that? No, I don't think we want to print that. That's the value that we're going to use for inches, right? Because we want inches to equal 0, then 10, then 20. Yeah, that's what we want. So what if we did this? What if we said something like this? What if we said inches, assign it the value I times 10, okay, and let's cut that out of there and paste it in here. Okay, and then let's print inches. So let's just say that we want the beginning of the sentence that's going to print out. That's going to be our table. So let's use the variable inches to get the number. And then let's just say inches is equal, I can spell, to, okay, and that's all we can say right now because we haven't calculated the centimeters yet. Okay, so that's good. So let's give that a run and let's see what this looks like. Oh, that looks good. 0 inches is equal to, well, we don't know. Then up to 100 inches is equal to, well, that's looking pretty good. Okay, so now in this processing, we've got to find a way to calculate centimeters. Well, don't we already have code that does that? Yeah, we do. Centimeters equals inches times 2.54. So I'm going to cut that out of there because we're going to get rid of all this pseudocode when we're done. Now I have to do that before my print statement. Okay, so now I have the centimeters. Okay, so then let's say the next thing that we want is the number for centimeters, and that's just the variable name, centimeters. Okay, and then comma, and then let's say centimeters, a character string, and a period. So we're going to say so many inches is equal to so many centimeters. Well, that looks good to me. Let's see how that works. Let's give that a run. Well, that looks right to me. Okay, if 1 inch is equal to 2.54 centimeters, then 10 is equal to 25.4, and 100 is equal to 254.0. That looks like what we want. Okay, so let's look at what we claimed up here in our comment. A program to print, let's see if we can get back to English here. A program that prints a table of conversions from inches to centimeters, one entry in table from 0 inches to 100 inches by 10. That, I think, does what we claim to do. Okay, now, could we make it an interesting table with lines and all that kind of stuff? Yeah, we could. It's a pain in the rump. Okay, for right now, I just want to show that we know how to do the calculation 11 times and to format the output to be useful to users. Okay, so now I want to pretty this up. I've written the code, I've tested it. Am I done? Well, no. We don't want to leave things in the code that we don't need. Okay, so for instance, the first comment, well, that's the name of the file. Well, in fact, let's go back to that file colon, kind of like that. Okay, and then the next 2 lines, they kind of describe what the program is supposed to do. That's okay. All right, the pseudocode. Does the pseudocode add to our understanding of the program? Well, people would argue yes, okay, because we're so new, we want to see how the pseudocode corresponds to the code. But the problem is we don't want to leave behind any comments that could get out of date. And if we have the pseudocode and the code, and there are two things, what's going to happen when somebody comes in here to change the code when we need to maintain the program? Well, if they're anything like the rest of us humans, they're probably going to change the code but not change the comments. So we don't want any play-by-play comments. So pseudocode was a nice way to get us started, but we're going to get rid of that. And typically we want 2 blank lines. We still have 1 extra one, okay? And then between the main code and the call to main, we want 2 blank lines. Okay, it's only 1 blank line. Let's give it 2. Okay, that looks good. And I'm going to make sure I save it, even though I don't have to. Somehow I'm kind of old school. I can't get used to that. And now I'm going to. I don't see a play button up here. I don't want to count on this being the same. In fact, let's close this console. There's a little extra close console. Let's do that. And then let's come over here. Let's right-click in the editor and say Run Chapter 2 Exercise 4. And it ran it again. Now, I think I'm done. Okay, so I think you've had the full C1 experience, and you're ready for the Do One experience for Chapter 2, Exercise 4. And I'm going to be moving on to the next one in just a moment. Okay, so what's the next one that you guys are going to be doing? Well, it looks like you're going to be doing Chapters 2, Exercise 5. So here it is. Modify the futeval.py program so that the number of years for the investment is also a user input. Okay, so we're not going to do it, as I remember, that was just for 10 years, and this is going, you're going to do it, you're actually going to prompt for that, and then you're going to do it just the number of years that you're asked for. Make sure to change the final message to reflect the correct number of years. Okay, well, I'm not going to do that for you, but I've created a program that's kind of like that. And we're going to go explore that now. So let's find the similar one. Okay. And this one's called times 10. .py. So let's, again, I think I activated the window with PyCharm in it, and then I pulled this over and dropped it up there. Okay, and I'm just going to say okay. It's going to put it in there with the proper name. All right. I think you know what I probably could have done to get it to copy? I could have done a copy paste. In fact, let's redo that. I'm going to Command Z to undo that. Well, that didn't work too well. Well, if I'd done a copy paste, we'll do that the next time. Instead of just pulling it over, if I had done a copy in the Finder and then I had done a paste on the project name in PyCharm Edu, I think I would have gotten a chance to rename it, and I also would not have consumed the file from the Finder. As you can see, I've been consuming the files over here, which is not what I wanted to be doing. But you know, you live and you learn. So times 10, let's take a look at that. Okay, so this is a program to compute the value of any input value times 10. This is done through repeated addition, just because. So the formula in futeval is just it's just a formula that needs to be evaluated a number of times. Okay, and in fact, when we're given the problem, it needs to be run. You know, you need to loop through it 10 times in order to get the job done. Okay, well, that's a fancy future value finance calculation, but what if we wanted to simplify that? Well, let's just do something where we're going to get a value from the user here, and we're going to multiply it by 10 by, we're going to do it just by brute force adding it together 10 times. Okay, and that's going to simulate what if you had to do something 10 times. Okay, so what do I have here? Well, here's how I start. I start out with a polite expression of what the program does. This seems to be something that our textbook author likes to do. And it's a polite thing to do. At least when you run the program, then you know what program that you've run the right program. What value am I going to use as the value to be multiplied? So I need some input there. So I'm going to use the standard way to get that input. Okay? And remember, if you wanted to do this eval and input as 2 lines of code, you could. And in fact, before I move on too far, I'll show you that working. Okay? We need a place to, so this is the original value that we got from the user. Okay? We'd turn it into a number. All right? And then we have to calculate some kind of end value. What's the value when it's multiplied by 10? And the way I do this is kind of brute force. I have a loop that goes around 10 times. You'll remember this for I in range at 10 is going to have values for the loop index I. It's going to be 0 through 9. But we're really not referring to it, so we don't even care about that. We just want to go around 10 times. That's what it's going to do. And I'm going to compute. This is a lot like the computation in the feud val. I say n value is assigned n value plus original value. And you have to remember that this isn't some insightful algebra. This is very procedural code that says take the expression n value, which is take the current value that is referred to by the variable name n value, add it to the value that's in the that is referred to by the variable name original value, add them together, and then put the sum, associate that with the variable name n value. So the first time through, it's going to go from 0 to 10, the second time to 20, to 30, to 40. It should go up to, I'm just assuming that we put in the number 10, right? Let's put in the number 5. So it's going to go 5, 10, 15, 20, 25. It's going to go up to 50, right? And then we're going to print out the n value. So let's just run this, okay, and put in the number 5. All right, so let's run it. Again, we're going to run the code as we get it. Okay, enter the original value to be multiplied, 5. Enter. The n value after being multiplied by 10 is 50. Well, that sounds right. Okay. Now, I said I was going to show you this thing again where if you're not comfortable doing this very Python-like thing here to do the prompt and the conversion to an integer in one thing, you can put it into 2 parts. Okay, so here's what you can do. You can take this input line and you can put it on have it be its own line of code. Okay, so I'm going to cut that from there. Okay, so I'm getting the input, but I'm not assigning it to anything yet. So what do I want to call this? Well, here's what I usually call it. I want to assign something to that. Okay, and I need a variable name. Well, what am I getting in? Well, I'm getting in the original value. That's what I want. But it hasn't been converted from a string yet. That's what eval does. So let's call this original value as string. Things that people type in at the keyboard, or things that people type into web forms, typically come into your program as character strings, even if they are what do I want to call it? Even if they represent numerical values, they are the character version of them. Okay. Unexpected indent. Okay. Oh, perhaps we're indented one more than we're supposed to be. All right, that problem went away. All right, original value as string is that, and then we can say eval original value as string. And there it is. You can just pick it off the list and click it, double click it, I guess. Original value as string. So that does the same thing in two motions. Okay. Now this putting expressions inside of expressions, so you don't need multiple lines of code. That's something that this kind of programming language lends itself to, which is why I say when we typically do that all on the same line, it's very Python-like. That's the typical style for Python. In terms of the efficiency of this code, this two-line version of this is perhaps just a teeny bit less efficient than the one-line version, and you'd have to prove it to me. We'd have to run it 1,000,000 times one way and a 1,000,000 times the other way, and then just see how different they are. I don't think they're really that different. Okay. So we've got this. Let's run this again. Okay. We don't have a run thing, so we'll right-click and run. And here we're going to put in 5 again. And that's it. Okay. So what do we say that we want to do? Well, we want to modify this so that the number of times that we do this is variable. Oh, well, that shouldn't be too hard to do. So what are we going to call this? Okay, so let's take this and give it a new name. How do you rename things? With refactor rename. So go over in the panel, highlight it, right click, refactor, rename, and again, I've not told you to call it anything. So this is going to be chapter 2 exercise 5. All right, that's what that's going to be called. And the difference is that we're going to have the number of times that we're going to go around. We're going to do. We're going to take a second input value. So program to compute the value of any input value times any other input value. Okay, this is done through repeated addition just because I needed something simple for you to do. All right, so what do we have to change? Well, how about the polite title that comes out at the top? This program, let's say, computes the value of any input value times, let's say, any other input value. Input value. Okay. Okay. Now, is it going to work for any input value? Well, you know what? I'm going to tell you that because of the way that we do this, because we're doing multiplication by addition, it's only going to work for integer values, right? All right. Well, if we want to multiply something times 3.5, can we put 3.5 in for the second one like we put in 10? No, we can't. Okay. So let's change this by times some other integer input value. Okay? And we're going to say computes the value of any input value times some other integer input value. All right. So enter the original value to be multiplied. That works fine. And do that. And I tell you what, why don't we go back and simplify this? Okay, so let's take this input, and we can factor this right back into where we had it. We're just going to eval this. We're going to get rid of the middleman. Okay. All right. So each of those was a refactor. One was to make it easier to understand for the beginner, and then the other one was to make it consistent with more typical Python coder practice. Okay, so all right, let's test it. We shouldn't have changed it. So if we put in 5, it puts out the wrong description, but let's put in 5. It should give us back 50. Yeah, that's good. All right, now the second thing we need to do is that we need to get how many times we're going to do the adding to simulate the multiplication. So we need another input. All right, so let's copy this original value. Okay. Okay. All right, and what are we going to call this? Well, let's not call it original value. To line it up right. Let's call this integer multiplier. Value. Okay? That's the second one that comes in. We'll remind ourselves that it has to be an integer. And then we're going to say enter. Let's just say enter an integer multiplier value. Okay? Enter an integer multiplier value. Okay? All right. So what are we going to do with integer multiplier value? Well, we want to change how many times we go around. That's all. That's all that controls. Instead of 10, which was fixed before, now it's going to be variable. So let's just go in here and put in integer multiplier value. And again, we can use the autocomplete with a double click there. And we have to make sure we get the message right. So the end value after being multiplied by 10 is end value. Okay, so we don't want to say by 10, so let's say by, and then comma. Okay, and then we're going to want to say is end value. Okay, and instead of 10, let's say integer multiplier value. Right there, multiplier value. And then each of the arguments takes a comma. So we're going to print this character string, then integer multiplier value, then the character string is, then end value. I think that's going to work. Let's do a little testing. So let's run a test. Enter the original value to be multiplied, 5. Enter the integer multiplier value. Well, let's just see. We're multiplied by 10 before. Let's see if we're able to reproduce it. 10. So the end value after being multiplied by 10 is 50. That sounds good. Okay, so let's see if we can use a different value. Okay, it should work for 5 times 5. Okay, instead of 5 times 10. So let's run it again. Okay, the original value is 5. Good. And the multiplier value is, well, let's say 11. 11. 55. That's great. Now, because of the fact that we're not really multiplying, we're simulating the multiplication by repetitive looping addition, which happens very fast in this computer. So as long as we're not using really big numbers, it's not really going to be a difference that we can really tell as a user. So that's kind of cool. But we can't multiply by real numbers. We can't multiply by a number that has a fractional part, only integers, because we can't do the add loop a portion of a time. You know, we're not really doing multiplication here, we're simulating it. So what happens if we say that we want to we multiply 5 times 10.5? I'm thinking that's going to blow up. Let's just see. So first number is 5. And the second number is 10.5. Kaboom! Okay. Now let's just see if we can figure out how this manifested itself here. Okay. We can see that the first problem happened in line 19. Okay. That's when we did the call to main. Okay. And then that transferred to line 14. Okay. That's in main. And that's for I in range integer multiplier value. And it says here, and you can see that's the line that got us. And it said, the float object cannot be interpreted as an integer. Well, we're going to learn in the next chapter that these values that we type in have a type. And if we put in a fractional part like 10.5, it goes into a type called a float, which is a real number that has a fractional part. Well, what's the problem? Well, we can't use it as one of the values in the range. It's looking for an integer value. And why? Well, because it can't do the loop a fractional time. It can only do the loop an integral an integer value of times. Okay? Could we do it 0 times? Well, let's see. Let's see if it happens if we do it 0 times. I don't even know if this works. You would think that we would get a 0. Does it work? Drum roll, please. 5 times 0 equals 0. Whew. Okay, well that worked, but I can't say that I put a lot of thought into it. Okay. What happens if we have a negative number? Will that work? I don't think it will. Let's see what happens. 5 times negative 22. Now, if we were doing real math, that would be a negative 110. But here, oh, I'm sorry. That's not going to work. Let's do it again. That's not what I was trying to do. So let's put, we want to multiply 5. All right. And we want to do it a negative 22 times. And it says, it doesn't blow up. It's just 0. Well, so it turns out that we probably want to tell them to say, put in a positive integer, right? So let's change our times sum instead of other integer input value. Let's say positive integer input value, okay? And change the other comment, some positive integer input value. And then let's say enter a positive integer multiplier value. Okay. Put an E on positive. Okay. Now again, I always want to make sure it's saved. It makes me an old guy, I think. All right, so let's run it again. And we can say 5. And we want to put in a negative 22. We go, oh, no, that's not what it told us to do. Let's just put in 22, 110. All right? So we have a program here that will give us the right answer if the users follow directions. It's not going to blow up, and that's the best we can hope for at this point in the course. So that's it for this one. I would say that in terms of the C one, you've seen one. Now it's time for you to do the do one on the real Chapter 2, Exercise 5. And I'll see you again soon. Okay, so we're back for the tutorial version for the last thing that we're doing. The last thing that we're doing is exercise 9. Write a program that converts distances measured in kilometers to miles. So this is a conversion program. Okay, we're going to write this one from scratch. We're not going to do this one as a maintaining code that's already there. Let's try to do it from scratch. It's going to be a lot like one that we've done before. Okay, now what am I going to do? Well, what I'm going to do is I'm going to do one that's like this. Instead of kilometers to miles, I'm going to do quarts to liters. Okay, so it's a conversion from the English system of measurement to the metric one, and that's it. Okay, so let's do something from the ground up. So here's what I'm going to do. I'm going to go up to the menu and say File, New. Now that doesn't seem to be working. Oh, I know what I want to do. I just want to highlight the name of the project and right click and then say New. Python file. Okay, and again, the exercise doesn't really say a particular name for the program, so I'm going to call it Chapter 2. Chapter 2. Exercise 9. Because I can. Okay. All right. And what have we been doing? Well, we've been putting the name of the file up in the beginning. That's a pretty good practice. So chapter _2 exercise _9 .py. Okay, and I'm going to toggle that into a comment. I'm going to use command // if you're on Windows. It'll be control // And the second thing we've been doing is having a this sentence that kind of describes the intent of the program. And I'm going to say convert a measurement in quarts to a measurement in liters. It's that easy to do. Okay, and again, we're going to toggle that into a comment. All right. Okay, so if we were ready to write our code, we would just do our main. Okay, and we'd put our main code in our main. We really haven't done anything big enough now to have procedures that we call from main. I mean, that's what we're eventually going to do. We're going to take the code in main. When it gets too long to really be understood well by reading the code as it is, we're going to refactor it into calls to other methods. Okay, and I think I showed you how to do that last week. But we're not going to do that. All of our code is going to go into main. But let's do pseudocode first. Okay, so And let's also try to identify a kind of a pattern that we're going to use. Well, one of the patterns that we've used, and it's really so basic, is it's almost more basic than a pattern, but it's called input process output. So I'm gonna put the kind of pattern words into all caps. If I can get my caps lock on, I can. It doesn't seem to want to work. So input, and I'm going to give myself a little room. And I'm going to say, then we're going to do our process. And then I'm going to give myself a little room. And then I'm going to do our output. Now, all this code is eventually going to go into main. Output. Okay. And also, you know what? There's a tradition that we've kind of inherited here of giving some kind of a polite synopsis of the program in the beginning. So let's kind of add that as part of our overall pattern. Okay. So I'm going to say be polite. Be polite. And I put these in kind of high level, I put these in all caps because they are, you know, they're really like sections of the solution that we're going to do. Okay, so how are we going to be polite? Well, we're going to do that by printing, right? So we're going to give the pseudocode version of that. So the pseudocode version of that is print, and we don't have to put it in parens because this isn't real code. Let's just take the description of the program and say that we're going to print that. We're going to print something that kind of looks like that, right? That's how we be polite. All right. Now, not everybody does this, but this is what the author of our textbook does. So we're going to do it too. Okay. So input. Okay. We're going to have to get something in quarts. We're going to have to get a measurement in quarts. Okay. So let's say prompt. That's where we write something out and we get something that prompt for measurement in quarts. Okay. And I'm going to say something like get quarts. So we're going to get the value and put it into the variable called quarts. Okay, that's good. So we come out of there. We've got the variable in quarts. Okay. So now we're going to have to process it. Well, usually this is in this kind of a converter. Well, it's just a one-line conversion where we assign an expression to the variable that's going to hold the output. So the output's going to be liters. So let's say liters, and let's have equals. I can't emphasize enough that equal sign is just assignment. Liters gets assigned the value of, and then we've got quarts, and that's going to be times. And I happen to know that the formula is 0.94635296. I'm hoping I'm going to be able to copy this from my regular machine to my virtual machine. How did I find this out? I Googled it, and I saw that there seemed to be a pretty good agreement about this constant. There it is right there. Okay. So I got it fair and square right off the web. Okay. All right, that's fine. So I've got liters, and now I need some kind of output. All right. So if I'm going to output, I'm going to print. right? Oh, that's a real line of code. So I wanna turn that line of code into a comment. I'm gonna toggle that on. Okay, so I'm not going to get the editor interpreter too worried, right? And then down here, I'm going to want to do some kind of print. And again, I don't want it to be real code, so I'm going to print what I'm going to say. I'm going to print, let's see, let's say quartz. Okay, so we're going to want the number that's in quartz. So quartz, and then we're going to want to say quartz, and quartz is equivalent to, and then let's say liters, the variable, and then let's say liters period the character string, right? Oh, I wanted to put that in. So what have I done? Well, it's a pretty simple problem, but I've gone back to basics and said, well, let's do this as a pseudocode. And then within the idea of doing it as a pseudocode, you know, we remember, hey, this is probably going to follow the model input process output. So we kind of put those up as kind of general pseudocode categories. And then we go, oh, well, let's have a be polite category as well. And then we just have a line or two of code under each of them to get it done. All right. So you know what I'm going to do? Now I'm just going to take my pseudocode, which I'm happy with, and turn it into proper Python. Okay. Am I going to keep the pseudocode in the end? No, because I don't think anybody's going to maintain it. Okay. And I think the code's going to be pretty readable when it's turned into Python. So the pseudocode is just for, you know, my work, and then I'm going to delete it. So okay, so we're going to need a procedure main, def main parens colon. Okay, and we're going to have some code here. All right, and then down at the bottom we're going to have a call to main. All right. And that's fine. So now we have to figure out what's the code going to be in main. So what do we do first? Well, we be polite. We've got to print. Okay, now let's type in a proper print here. Okay, so now we're indented, so we know we're in the main. Print, and now we have to get the syntax right. In parens, in double quotes. Let's just say, convert a measurement in quarts to a measurement in liters. Okay, this is just kind of a nice, polite title, so we know we ran the right program. Okay, put a period there. That looks good. All right, then that part's done. Now I'm going to go right into input. Do I want to skip a line so we can tell what part goes with what part? Okay, let's do that. We can skip a line here. I've in the editor that we have here, you can't easily skip the first line. That can lead to problems. I think you can't put a comment on the first line. Does that go wrong? No, that doesn't go wrong. I had something going wrong the other day, and I was just going absolutely crazy. But I can't trigger it now. Okay. So let's put a blank line in between our two main sections. Now we're going to go on to input. Prompt for measurement in quarts. Okay, so let's do it the fancy, kind of more experienced Python coder way. Quarts gets assigned the value eval, and then the value that comes from input, and then the argument to that is the string that we want to prompt with. And what do we want to say? Enter a measurement in quarts. Okay. And we're going to put a colon there because that's what the author has been doing. And you remember the author has actually been putting one space here so that we're not having to type in right after the colon. Okay, so that's the input. That's the whole thing right there. We did it in one line of code. All right, so let's skip a line, go down to process. Well, you know what? Even though it was pseudocode, it was so close to Python that it was Python. So let's just take that and copy it. And we're going to skip a line. We're going to put that. Okay, so that's our process. Right? Looks good. And the smart editor seems to like it. And now let's do our output. Print quartz. So let's say print, well, small print, print parens. So quartz is the variable name. Okay, then a comma. Then what's the next thing? Oh, this character string. Well, you know what? It's right here. Let's say quartz is equivalent to. Let's just copy that right on down, right here. Okay, did we have to worry about the space in the beginning and the end of that character string? No, because of the way the print works, it's going to put an extra space after the number that's in the variable quartz, and it's going to put an extra space after the character string is equivalent to. So we don't have to add there. Okay, and then let's say, what comes next? Liters, the variable name, comma, and then let's copy the text we had up here, liters in a character string. Oh, that looks good. So let's see, be polite, input, process, output. Well, let's see if this works. Okay, this should work. So let's right click and say run chapter 2 exercise 9. Okay, enter a measurement in quartz. Oh, let's try 1. And it's equal to 0.9 blah 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 blah. Oh yeah, that's the same. That's the literal constant that we used in the program. So yeah, if our formula is right, that ought to be right. Okay, let's try it again. Let's do something. Let's say if we had 12.9 quarts, okay, what would that be equal to? Well, you know what? You'd have to get your calculator out to test that. Okay? And I can tell you in anticipation of the chapter that we're going to do next, when we're going to talk about number values, that we might find that our calculator might be off by just a few of these low order digits. Okay? Probably not, but it could be. But it's going to be very close to the number that we're looking for. Okay? And then here's what I'm going to do. I'm going to try one where I'm going to copy this constant. Okay, and if I give it that many quarts, I'm hoping it's going to say it's 1 liter. So let's copy that into our thing. Let's say we want to run. Let's go there and paste that. Well, I can't do that. Try a Command V. Pasted it. And interestingly, no, that many quarts is equal to less liters. I've got my math wrong. Yeah, 2. It would have to be 1 over that, wouldn't it be? Okay, so one of the things that you're going to see is that these real numbers, these ones that are kept in a Python time called float, that they have little rounding errors in them. Okay, I don't know if we did this in our calculator, we might get a number where the low order digits were just a little different than this. We'll see, and we'll get to that with the next of the chapters. So I'm going to assume that this works. I'm going to do it again. I'm going to say, what if I have 10 quarts? Well, that's different by a factor of 10. Let's run it again. Let's say I've got -1 quarts. Can I do that? Yeah, it gives me a negative answer. Now, can you have a negative quarts? Well, in certain ways of thinking. Let's say, you can be ahead or you can borrow. There would be a third where you could have, you could be behind by a quart, and that would be 0.94 blah blah liters. That's good. Can we give it no input at all? Well, that's probably going to blow up. We've kind of shown that before. Yeah, it didn't like that. Unexpected EOF, end of file. Good. And could we give it a character string? Like, let's type in the character string, hi mom. Let's see what it likes about that. No, it doesn't like that. Okay, so it doesn't like that at all. Okay, so that makes about sense. We get to the point eventually where the obvious user errors we don't have to test for, because we know at this point in the course we're only testing for kind of, well, we're not testing for a lot of user errors at all. At this point, we're saying if we trust the user to input exactly what we tell them to input, will it work? And in this course, I think it will. Again, if we come back here and we say we've got 50 quarts, we're going to have 47 and a fraction liters. And again, I could do the math with my calculator. I probably should, but that seems about right. Okay, now, are we done? Well, no, we're not done, because we've left in some of the crutches that we used while we were coding. And if this were a real product that we were going to do for a client, we wouldn't want to do that. And again, why not? We don't want to look like beginners? No, not so much. The thing is, we don't want to leave comments in our code, whether they're actual comments that are meant to be temporary, or lines of code that we disabled by commenting. We don't want to leave them there, because we only want to leave behind the real live code that people are going to maintain. Okay, so I'm going to get rid of my pseudocode here, like that. And I've got too many blank lines, so that's good. And I've got maybe too many blank lines here. I'm aiming for 2. That looks like 2. That's good. Now, do I want to leave the blank lines in this one? I can say, as a beginner, where I really want to be able to look at this and say, input, process, output, does this work? Well, I think that could be okay. Now, could I put in some comments? Could I leave some comments? Could I have one here that says maybe comment input? Oh, sorry, I did that wrong. The line before, I was thinking, could I say this is input, and then I come down here and I go, this is process, and I come down here and I say, is this output? Now this is kind of a beginner thing to do, but that's okay with me. Would people continue to organize the code under those comments? Yeah, I think they probably would. I think that would be okay. Or you could do kind of the very experienced kind of version like this. There isn't anything that's wrong with just taking all the blank lines out of this altogether, and have just show what gets done in what order. And this is a program that's really simple enough that you're able to look at it and going, oh, this is a pretty simple input process output thing. Now, the one last thing that you want to do after you make any change to the program is you want to run another test. Make sure that your cosmetic changes have not changed the code. This kind of cleanup that we did is another kind of refactoring. It's changing the code, but not trying to affect the functionality. Okay, trying to make it more readable, more maintainable, more testable. So we've got that. Let's give it a run. And now we're going to say we've got 10 quarts, and it says we've got over 9 liters. That looks just right, and then I'm ready to save it. And right now I've got my 4 exercises. They're not what you're going to be doing, because you're going to do the real ones instead of my parallel ones. But I'm going to take this and zip it up and hand it in, and I'm all done. So that's my C1 for exercise 9. Good luck on your do one. Try to do it from scratch, because that's what that's a skill that we're trying to get you to learn. And I'll see you next time. Bye bye.